Well, welcome back. And now we are going to be talking about reversing cancer. Reversing cancer naturally. And first of all, before we talk about reversing it, we need to understand it a little bit and get into cancer and what cancer kind of is. And then we can talk about things that we can do in regards to it. So cancer is a collection of related diseases. It's not just one disease, but it's a bunch of different diseases that are very similar to each other. And in all types of cancers, some of the body cells begin to divide without stopping and spread into the surrounding tissues. And cancer can start almost anywhere in the body. Normally what happens is your cells will grow, they'll divide, and when they need to, they'll die. They only have a certain number of divisions that they have, somewhere around 50 or so divisions, and then it's supposed to die at that point. Or there are sensors or receptors that tell if it's pushing into others around it. And if it is, then that signals it to die. Or sometimes if it has some kind of malfunction inside of itself, then that's a signal as well for it to die. But in cancer, this order breaks down, right? It doesn't work the way that it's supposed to, and cells can survive when they're supposed to die, right? They survive when they're supposed to die. And new cells form when you don't need them. And cells divide without stopping. Now, many of us get the idea that cancer grows very quickly. But in certain cancer cell lines, we find that cancer actually doesn't grow that quickly. If you compare in the cells that form blood cells, all right, and the precursors that form blood cells, you have one human myeloid progenitor cell. So that's like a stem cell in the cells that produce blood cells. One of those stem cells can make approximately 10,000 daughter cells in a week. All right? So one of them can end up being about 10,000 in 1 week. That's how fast that normal cells can, in these lines, can divide and reproduce themselves. But when you look at leukemia, when you have leukemia that involves this same cell line, in a week you only get about 2 to 3 daughters or daughter cells from a leukemia cell. It actually doesn't divide that rapidly compared to the normal cell lines. But what does happen in the normal cells doesn't happen in the cancer cells, and that is that the normal cells get these signals to die. And so they will die off when they need to. And there are inhibitory signals that can tell those cells to slow down or to stop their division. But the cancer cells don't respond to any of that. Right? So they might be dividing slow, but they'll divide consistently. And you know that the turtle beat the rabbit. Why? Because the turtle was consistent, persistent, even though the rabbit had fast spurts going along the way. Now, what does it mean when a cancer is malignant? It means that the tumors can spread into or invade nearby tissues. So we have an idea of malignancy down here in the caption or the picture on the bottom. And you have a cell that has this mutation. It begins to grow, and it doesn't respect its neighbors around it, and it just keeps growing or overgrowing. And as it overgrows, it starts taking over more territory around it and invading, then starting getting into some of the other tissues that are there. That's called a malignant tumor. Now you might have a benign tumor, and the benign tumor, then it does the same thing. It grows and it gets larger, but it doesn't invade. It doesn't go into other tissues. It stays in the same tissue where it's at. But benign tumors could kill you if they're in the wrong location, like inside the skull. You can have benign tumors that grow inside the skull, and those benign tumors inside the skull, they grow, and they might not invade surrounding tissues, but you only have a certain amount of space inside your skull. And so that tumor can grow and can push on the brain and cause you to then have serious dysfunction associated with it. Now there's malignant, but there's also metastatic. Metastatic means that it can break off and it can go to distant places. It might go through the lymph system and through the lymph nodes. It might go through the blood. It might go through various different things from that standpoint. But that means that it can travel to different places and it can spread. Right. Now, cancer cells are not as specialized as normal cells. All right, they're less specialized. So normal cells, they have very distinct functions. They look very distinct as well. They are limited to certain functions, right? So muscle cells have a specific function that is different from thyroid cells, which has specific functions which are different from liver cells, which have specific function which is different from bladder cells, right? They're very specialized based upon the need of what's there. But when you look at cancer cells are not really that special, or specialized, I should say. And you can notice differences in them when you look at them under the microscope. I don't think most of us are going to be taking cancer cells and looking them under the microscope, but they do look different. And they don't like to obey signals, right? So if you run over the stop sign instead of stopping at the stop sign, sometimes you can get into some serious problems associated with that, and that's exactly what we find with cancer, is they run those red lights, those signals that tell them to stop, and they keep going, and it creates significant problems. Not only that, cancer has the power of influence. So you might have a tumor that's growing here, and it's getting bigger and bigger, but you can only supply or support a certain sized tumor without it breaking down, because you've got to be able to get all those nutrients. Remember, cells have to have oxygen and water and sunshine and food and so on. So you've got to be able to get those things that the cells need to them so that they can function. But if it gets big enough and it doesn't have a good enough blood supply, then the cells on the inside will start dying, or the cells that are far enough from the blood supply will start dying. And so the tumor cells have chemicals that they'll release that cause blood vessels to grow towards them. It's called angiogenesis, or the development of new blood vessels. And so it draws that blood vessels to them. The blood vessels grow to the tumors so that it can support it, supply the nutrition and everything that it needs so that that cancer can grow. And cancer cells can hide from the immune system. The immune system normally removes damaged or abnormal cells from the body, and some cancer cells are able to hide from the immune system by, one, they can build a fibrous capsule around itself and then prevent itself from being discovered. So you've got this kind of fibrous capsule or wall that's around it, and it prevents things from finding it, just like this little kitty, right? Or the cancer cells can produce immune suppressive hormones, hormones that suppress the immune system and keep it from acting like it's supposed to. Cancer can also, or tumors can also use the immune system to stay alive and to grow. They can attract populations of immune cells that are inhibitory immune cells. Some of the immune cells are inhibitory, meaning that they stop or they decrease the immune system's response. And so some of these cancer cells can attract those immune cells to itself to then inhibit more of the immune system from functioning around them. Right? And and keep the immune system from keeping it under control. Right? And of course, cancer is associated with genes. It's a genetic disease, meaning that it's caused by changes in the genes and the ways that our cells function, especially how they grow and how they divide. All right? So the genes that control the cell function, that control cell growth, cell division, and cell death are the typical genes that are associated with cancer. And these sometimes can be inherited, but it can develop in a person's lifetime because of damage to the DNA. That can be through substances, or that might be through radiation. You can even have infectious agents like viruses. We know that there are a number of cancers that are associated with certain virus infections that can mess up the DNA and then lead to these changes. So if you have genes that are responsible for the cells to grow, well, if you have some kind of mutation that turns on that gene or makes it so that it's overactive, then that can lead to cancer. If it's one that helps it in the dividing process and that gets increased, then that can help it to be cancer. Or if it's a gene that causes, that's involved in the process of causing the cells to die, well, if that one gets messed up and it's not working, then that can lead to cancer as well. And of course, as we saw before, you can mess things up, and when you mess things up, the lettering of the DNA sequence, then you don't get useful information from that standpoint. Time to dream versus tame to dream, that's a single letter change. You can reverse your order so that now it's admit to dream. You can delete some ones, delete the IM from time, and now it's tetodre-M. And you can insert extra ones, extra letters in that DNA code, like an I, and now it's Tim et odrim. Right? It doesn't necessarily make sense, right? You can mess up the DNA, mess up the sequence. Now it doesn't function the way that it's supposed to. But not only is it messing up the DNA, we talked in our first lecture last night about epigenetics and the epigenome. And remember, you have tags that you can add to the DNA. Here they show them as little flags in the picture, right? So you have these tags or flags that in your healthy cells, these tags are correctly placed and the genes are expressed in the right proportions. But in many tumors, those tags are incorrectly applied. And so certain genes that should be down-regulated are up-regulated, and so you produce a lot of those genes when you weren't supposed to. Or those that should be there to like suppress cell growth and so on, those genes get suppressed, so it doesn't suppress the growth, so it keeps growing. Right? So you can have a change in those tags, and in fact, that's exactly what we see in cancer. We see that there's a lot of changes in the epigenome and those tags on the genes, and as cancer progresses and it gets farther and farther in its process, there's more and more epigenetic changes that we see in the cancer cells. All right. Now, each cancer has a unique combination of genetic changes. Right? Each one has a unique combination of genetic changes. It's not that you can say, okay, well, since you have breast cancer, now your breast cancer is like everyone else's breast cancer. No, because there are different mutations that lead to the breast cancer that you have, or so on and so forth, or the individual has, right? And the additional, as that cancer, it begins with a certain few mutations, but as it continues to grow, it acquires more mutations. And so it changes over time as it grows, right? So if you knew what it was like at the beginning, you might not necessarily know what it's like later on. If you knew the exact genetic pattern and epigenetic pattern earlier, well, it wouldn't have the same genetic pattern and epigenetic pattern later because it begins to mess up or mutate even more. And different cells within the same tumor might have different genetic changes. And so these cells might have certain mutations. These cells here might have other mutations, but they're all part of the same tumor that have developed in the same region, right? And the cancer cells generally have more mutations than normal cells do. But that being said, cancer cells are about 99.9% the same as normal cells in the body. So they're remarkably similar to cells in your body, but there's few changes, but they're very important changes that happen in those cancer cells that change how they behave. Now these genetic changes, you can have proto-oncogenes. These are genes that are involved in normal cell growth and division. So they promote cell growth, they promote cell division. And when they are altered, when they're messed up, then they become oncogenes or cancer-causing genes, and they increase cell growth, they increase cell division. You've got tumor suppressor genes, and these are involved in controlling cell growth and division, so it slows it down, it doesn't go too fast, right? You can get the speed going just right. And when those get altered, then the cells divide uncontrollably. You know, some vehicles you have are governed, right? Depends on what type of vehicle. I know we had a go-kart, and the go-kart was governed. And, you know, so it could only go a certain speed, and then you figure out how to get around that, and you can pull that off, and you can rearrange things, and so you can go faster, right? Well, there's a governing process that's involved in that so that you don't go too fast, but the cancer cells get around that because of the mutation, and then they really get going fast. And then you have DNA repair genes. So there's genes that are involved in repairing the DNA because the DNA is in a cellular environment where there's a lot of trauma that you can get from environmental factors, right? And the DNA repair genes are there to help to fix the damaged DNA. And so when they get messed up, the cells develop additional mutations at a faster rate because they can't get fixed like they did before, right? And so, which is one reason why as a cancer goes along, you end up seeing more and more mutations over time. Now, cancer is a problem, definitely, and the lifetime cancer risk in the United States in males is about 43.31%, so that means almost 1 in every 2 males will develop cancer in their lifetime. And the risk of dying from cancer is about 22%, or almost 1 in 4 males dying from cancer. And females, not quite so high. You've got 37.81%, or almost 1 in 3 females that will develop cancer during their lifetime, and about 19.26%, or 1 in 5 that will die from cancer in their lifetime. Right, so men appear to be a little bit more susceptible to cancer than women. Now, as you age, your risk of developing cancer increases. So if you're in the 50 to 59 age group, then you have about a 1 in 20 risk of developing cancer. If you are in the 60 to 69 year age group, then you have about a 1 in 10 risk of developing cancer. If you're in the 70 to 79 age group, then you have a 1 in 5 risk of developing cancer. And if you're in the 80 to 89 age group, then you have a 1 in 3 risk of developing cancer. And I don't know what it is in the 90s. They only give us numbers up through the 80s, right? So the risk obviously increases as an individual ages. And indeed, that's exactly what we see. And we find that the death rates associated with cancer and the the prevalence of cancer is growing over time. So in 2002, we had 2 of the states in the United States where cancer deaths were greater than cardiovascular disease deaths, meaning that cancer had outdone cardiovascular disease as the leading cause of death in that state. By the time we get to 2014, it's 22 states where cancer deaths are greater than cardiovascular disease deaths. And of course, the scientific community is looking at this and starting to project when is it when cancer is going to become the leading cause of death rather than cardiovascular disease, which has been the leader for, oh, I don't know, getting close to 100 years. Cancer's taking over as number 1. And it's a problem of aging, at least to one degree. The percentage of elderly, meaning those that are 65 years of age or more, sorry if you fit that category and you're offended by that, it's not my definition. The percentage of elderly in the population is increasing over time, right? So in the 1960s, it was only 9.2% of the US population that was 65 years of age or older. But now in 2020, they're projecting that it'll be almost 16%. In Europe, you're going from 10.6% up to 21%. So the percentage of the population that is older is getting bigger, and we know that from the statistics before that the older you get, the higher your risk is of developing cancer, and so hence we find cancer rates increasing. Of course, if we killed off all the old people, then our cancer rates would decrease significantly. Of course, our cardiovascular rates of death would decrease significantly, and so on and so forth. And all of the statistics would look a lot better, but it wouldn't be a good solution, would it? No, not at all. Not at all. Now, what is it that puts you at risk for developing cancer? Well, the one thing that we noticed, of course, was age, right? The older you are, the higher risk you have of developing cancer. Why? Your DNA's been around longer. And it's been exposed to a lot more stuff over a longer period of time. You have a greater risk of that actually turning into something. Individuals who are exposed to alcohol, whether, well, that's usually voluntarily, right? Voluntary consumption of alcohol, that increases your risk of a number of different cancers. There are a whole bunch of cancer-causing substances. We call them carcinogens. And I don't have a list here, but you can get lists of hundreds of substances that have been shown to be cancer-causing. Also, chronic inflammation. So if you have an inflammatory process in an area like a skin lesion with an ulcer, and the ulcer remains there for a prolonged period of time, well, that can actually lead to cancer transformation and development of certain cancers in that area, and chronic inflammation elsewhere. Dietary factors. We know individuals that eat an animal-based diet are at significantly increased risk of cancer compared to those who are on a plant-based diet. Right? And there's some other factors as well, like number of meals. So if you eat if you eat 4 or more meals a day, then you have a 90% increased risk of developing colon cancer and rectal cancer compared to those who are eating 2 or fewer meals a day. Right? So it's a diet, but it's also how you eat, and it's what you eat, of course. Hormones. Right? So we know that's a risk factor as well. If you have estrogen replacement therapy, that puts you at increased risk for certain cancers. And if you have testosterone replacement therapy, that does as well. Yes?
What about people that smoke?
What about people that smoke? Well, we're going to get there. That's definitely tobacco is one of the big risk factors for cancer. Immunosuppression, so if you have, for some reason, your immune system is suppressed, whether that's because you're taking medications, let's say, for instance, you have kidney failure and you get a kidney transplant. And with a kidney transplant, you're taking medications in order to prevent the rejection of that kidney. because the body identifies it as abnormal or foreign, and so the body's going to want to attack that thing and destroy it because it's not you. Well, in order to prevent that from happening, you go on medication that suppresses the immune system. Well, on that immune suppressant medication, you're then at greater risk for developing cancer. Because what is it that's going to take care of the cancer anyways? The immune system, that's right. So if you suppress that immune system, well, then the cancer is going to have a good chance to get going. You have infectious agents. Again, there are many different viruses. We're discovering more and more viruses of the herpes viruses and papilloma virus and so on and so forth that we know are associated with cancer, cervical cancer and other types of cancers. Obesity. We know that obesity is associated with a number of different cancers, and individuals who are obese are at greater risk for cancers like breast cancer and colon cancer and so on. Radiation exposure. Yes? So what's one of the things that we do to treat cancer? Radiation. What's a cause for cancer? Radiation. So what's a cause for cancer? Immunosuppression. And what's a treatment for cancer? Immunosuppression, right? So we use the things that cause cancer to kill cancer, and then we get upset because we develop some other cancer because of the treatment for the cancer. Well, yeah. Sunlight, too much sunlight exposure, burning and so on and so forth, ultraviolet radiation, that can cause it as well. There's tobacco, so smoking, right? That's definitely a big risk factor for cancer across the world. Tobacco used to be the leading cause of death, not the condition that an individual has, but a behavior that an individual has that causes death. It used to be the leading cause of death around the world, and now it's diet. Diet is leading cause. So what do we do about it? Well, there's various different things that we can do for cancer to treat it. From a conventional standpoint, you're looking at things like radiation. We know that. Surgery and chemotherapy, but then there's also targeted drug therapies that an individual might use. So say, for instance, you have breast cancer, and you have estrogen receptor, progesterone receptor positive breast cancer. Well, you can use estrogen receptor blockers, targeted therapy for that, in order to decrease the amount of stimulation of those estrogen receptors so that the tumor cells don't grow as fast. They don't have that stimulus, right, that's going on. There are other targeted drug therapies. There's clinical trials and experimentation that's going on with National Institutes of Health in developing vaccines for different cancers and trying to vaccinate in such a way so that the immune system kind of wakes up, right, and realizes that, oh, hang on, I'm supposed to be fighting that thing, and then go after it and start fighting it. There's some interesting therapies that are being done in laboratories in which they are taking bone marrow samples, and they take part of the immune system, T cells, and they get those T cells and they sensitize them to the cancer that an individual has, so that they begin to recognize that cancer and destroy it. And then they get those T cells, they replicate them in the lab, and then they send them back to the place and they inject it. And then the T cells, which was the individual's own T cells, just replicated in a lab and sensitized. Now those T cells go throughout the body, find the cancer, and start destroying it. And there have been some remarkable stories of recovery from that standpoint with some of these targeted therapies. Well, it's interesting when you look at the growth of cancer and how much growth you need before you ever realize that you have it in the first place. So over here on this graph, we have a biological and clinical correlates of tumor growth. All right. So what's going on here is as you go up the chart, then that's representing the growth rate. It's growing faster, growing faster, growing faster, growing faster. As you go from the left to the right across the chart, that indicates the number of cells that are there or the weight of it. You have the weight underneath it and the number of the cells above it. So at the beginning, you begin with 10 to the 0 cells, which is 1 cell. So you have 1 cell that's a tumor cell. And so it grows and it divides and it becomes 2 and then it becomes 4 and so on and so forth. And it begins to grow and grow and grow and grow and grow. Well, by the time you get to 1,000, it's only a microgram. And then by the time you get to 1,000,000, it's only a milligram in size. And, you know, a lot of your medication is how many milligrams? You know, you take a little pill and it's how many milligrams in it, right? Not very much, right? Not very much of it in there. It's very small. Now that's 1,000,000 cells. It's really, and that's where you have neovascularization, meaning that you start having the new blood vessel growth to it by the time it gets about 1,000,000 cells, and starting to begin that growth of blood vessels and the ability to then metastasize or spread to different locations. And then you get to this point where you get to 1,000,000,000 cells, right? And it's not until you get to 1,000,000,000 cells that you're really at the area where we can then pick it up. Before 1,000,000,000 cells, you can't tell on scans and images and other types of things like that whether you have the cancer or whether you don't. So if you treat the cancer, let's say for instance you have, we'll just do the breast cancer because it's the most common one, that you've got breast cancer and you do treatments. You've got chemo, radiation, whatever that you do, or you know, dietary interventions or other things like that. And you had this larger tumor and the tumor gets smaller and it goes away. And it goes away and you can't see it anymore. So you do mammogram, you can't see it. You do ultrasound, you can't see it. You do MRI, you can't see it. It's gone. You are now in remission. Well, you can be in remission and you can have almost 1,000,000,000 cells in one spot and still be considered in remission, but you've got almost 1,000,000,000 tumor cells, right? But it grows a little bit more and it gets above that level and now they can see it again. Oh, now you've got relapse, right? You've relapsed. So it's not so much that the therapy causes it to go away completely and then it starts coming back completely. It never went away completely in the first place, right? The treatment never really got rid of it. Now, so this is another way of looking at it. So you've got the leukemia now. It's growing and it's getting a whole bunch of leukemia cells and you treat it. You treat it with chemotherapy or radiation or whatever you're doing, or bone marrow transplant or something. And then you decrease, the numbers drop off significantly. Drop. And it goes below that billion level. And now you can't detect any of it. And it stays below that. And it might stay below it, like in this chart is mentioning. It might be 1.5 years or 2 years. You're cured, right? You're in remission. You don't have it anymore. And we're very happy for your remission. And I'm very happy for your remission too. But there's still leukemia cells there. And then the cells begin to grow over time and grow over time and divide over time and divide over time. And finally it gets enough where you begin to see it again, right? And oh no, now there's relapse, right? It's come back. Well, then you try another drug or another routine or another whatever to treat it, and it goes back down below that level. Okay, you've got another remission. But then maybe it'll come back again and have relapse, right? So this is just understanding how it grows, and from a conventional standpoint, what treatments look like, and even from a natural standpoint, what we might see relative to cancer and cancer's treatment. Well, what are things that we can do naturally or at home and without expenses, too much expense, in order to treat cancer? Well, one of the things that we can go to, of course, is nutrition. As we looked at last night, nutrition is the strongest physical factor to affect the epigenome. Those little flags are those little tags on the DNA, to change them so it changes how the genes function. And we looked at that one study of Dean Ornish and his group with the low-grade prostate cancer, and we saw how significantly that diet and the intervention decreased the activity of those cancer-associated genes. So yes, diet is a big factor that can help in decreasing the activity of cancer-associated genes even when they're there. It can help to suppress it. We know from the research that fruits and vegetables protect against several different cancers, like mouth cancer, throat cancer, cancer of the voice box and the esophagus, stomach, lung, pancreas, prostate, and so on. All of those have been shown in research to be decreased or protected against by increased intake of fruits and vegetables in the diet. We also know that certain plant phytochemicals, or the plant-based chemicals, the nice ones that are in there, they also help to regulate hormones, which the hormones might be responsible or involved in helping to promote the cancer growth. It slows down the cancer growth as well and reduces inflammation and reduces oxidative damage from oxygen and its interaction and damage on various different cells, right? And oxidative damage is the very thing that you try to avoid by having antioxidants. Right? And fruits and vegetables are very high on antioxidants, right? So they help out from that standpoint. Well, we also know that cruciferous vegetables, and there's a bunch of cruciferous vegetables in the picture. I don't think it's all cruciferous because I see something in there that looks like an apple. Oh, no, that's,
Kohlrabi.
yeah, that's the kohlrabi. That is a cruciferous. All right. So cruciferous vegetables, things like broccoli, cauliflower, cabbage, Brussels sprouts, bok choy, kale, kohlrabi, right? All of those are cruciferous vegetables. And they have been shown to decrease cancers of the mouth, pharynx, voice box, esophagus, and stomach. Right? Now, we know it's more than that. But this is just what the research shows so far in regards to it. We know that it helps to regulate body enzymes and defend against cancer. And it can stop some cancers' cell growth. So cruciferous vegetables would be a good thing to include. Well, we also know that lycopene can be beneficial as well. You find that in tomatoes, pink grapefruit, watermelon, and apricots. All right, it helps with the pinkish red coloration of those fruits. If you consider tomatoes a fruit, and that helps to protect against lung, stomach, prostate, colon, mouth, and esophagus cancers. But don't get caught up into the supplement craze, because in the, I think it was the Harvard health professional study, they identify that increased tomato intake in the diet. Was that the Harvard Health Professional Study, or was that the Adventist Health Study? I can't remember. It was one of the large population studies looking at dietary interventions and its impact upon cancer. Anyways, what they found is that individuals who had increased intake of tomato products, whether it was tomatoes or it was pizza sauce or it was pasta sauce or other things like that, the higher tomato intake that an individual had, the lower prostate cancer that they had. And so, yes?
Yes, a couple people came through Tuskegee and they had the findings on that, and it was including all like the organic paste they made, tomato paste, like all the brewers would gather all that, and they start doing that, combining it with organic garlic, that old-fashioned heirloom garlic, and they have several men went through that process and they're cancer-free that were diagnosed with prostate cancer.
Right.
It was documented, so that was wonderful.
Right, so an interventional trial where they're using tomato products or organic tomato products along with the old heirloom garlic,
Yes.
and the use of those two things leading to the successful treatment of prostate cancer from a dietary intervention. All right, good. Well, in the large study, they were looking at the increased tomato intake decreased prostate cancer. And so they thought, well, what's in tomatoes that's special that might be causing that? Well, they thought, well, it's probably lycopene. So let's do a trial now where we give them lycopene supplements versus a placebo pill, and we'll randomize them into two groups, and this group gets the lycopene and this group gets the placebo pill. And let's see how they do. Well, they had to stop the study at about 2.5 years. It was supposed to go longer than that, but they stopped it at 2.5 years. Why? Because they found that there were more people in the lycopene group that were getting prostate cancer than those who were getting the sugar pill. And so they stopped the study. So it's not just the substance, it's the substance the way God packs it. Right? So when it comes together in the fruit, or the vegetable, or the way that it's packaged in nature, that's the best way to get it, not as a lycopene supplement in a pill. Also, there's research looking at soy and its beneficial impact upon breast and ovarian cancer. You look at that and you go, hang on, I thought you're not supposed to use soy in breast cancer and ovarian cancer, and what's going on with that? Well, there are conflicting studies that are out there. One thing that I will say is that the more processed that soy becomes, the less healthier it is for you, right? So if you have like textured vegetable protein or hydrolyzed soy protein or other things like that, it's probably not so good for you. In fact, the research is pretty clear, it's not. But if you have soybeans or edamame, which is the green soybeans, or even tofu or tempeh, all right, all of those have been shown to have beneficial effects. And then the question is, well, what about GMO versus not GMO? Well, there's probably effects from that standpoint as well. But even not teasing out the GMO versus non-GMO, the larger population studies looking at soy intake show that individuals that consume more soy tend to have less of these cancers. And there's some interesting new stuff coming out with breast cancer and ovarian cancer showing that there's not just one estrogen receptor, there's actually two. There's an estrogen receptor alpha and there's an estrogen receptor beta. And the beta receptor has some of the opposite effects of the alpha receptor. Now, the normal estrogen that you produce in your body primarily impacts the alpha receptor in the breast tissue. And so the more estrogen that you have, or if you have estrogen in birth control pills or hormone replacement therapy or whatever, then that will stimulate the alpha receptor, and that promotes growth in the breast tissue. The beta does almost the opposite. Well, what we've found is that soy primarily impacts the beta receptors and causes an opposite response until you eat about 42 cups of soy for the day, and then it becomes more of a prominent alpha receptor effect. So if you're really, really, really hungry for soy and you want to eat more than 42 cups of soy for the day, then yes, it could be harmful to you from that standpoint, but the lower intakes actually appear to be beneficial. Plus, the beta receptors in the bone actually help to increase the bone mineral density, and hence we have a number of studies showing that soy intake decreases osteoporosis and decreases wrist fractures and so on. All right, allium family. Here's your garlic. All right, the allium family. The allium family of vegetables is very good when it comes to cancer treatment. These are your garlic, onions, leeks, chives, scallions, and so on. All right, this family is very good as well. They have allyl sulfides, flavonoids, quercetin, They help to inhibit mutagenesis, or inhibit the mutation process associated with DNA damage. They change enzyme activities inside the cells and in the tissues. They inhibit the DNA from being changed, DNA adduct formation. And they help to scavenge oxygen-free radicals, so they're an antioxidant, and they affect cell proliferation and growth. In fact, in one study that was done looking at 9 different cancer lines and looking at 25 different vegetables and their impact on decreasing cancer growth but not affecting normal cells. Decreasing cancer growth but not affecting normal cells. The one food item that showed the greatest effect, garlic. Yeah, garlic. Out of 8 of the 9 cancer lines that they were looking at, garlic was number 1. And on the 9th one, garlic was number 2. And number 1 on that one was leeks. So the allium family is very good from that standpoint. So whether you like garlic breath or not, if you are looking at cancer or trying to avoid it, get to be friends with garlic. But it doesn't have to be raw. It can be steamed, you know, it still has anti-cancer properties to it. Well, what do you want to do? Well, you want to avoid highly refined foods. They're not so good for you. They look nice and yummy, and yeah, they're nice to the tongue and they're bad to the body, right? So you have highly refined foods, you have meat, including fish, and you have flesh and dairy products as well. And you have all of these nice fried foods. Oh, so yummy. And what do all of these have in common?
You love them, but they don't love you.
You love them and they don't love you back. That's right. All of these are oxygen-free radicals. They cause free radical damage or oxidative stress to the body. And an oxygen-free radical is a molecule that has an unstable electron group around it. And so it's a scavenger. It's looking for its missing electron. And so it'll go along and it'll find another molecule and it'll rip the electron away from it and pull it to itself so it feels nice and good. Well, now this guy is damaged, and he now wants to go around and find one from someone else, and he rips someone else off, and they become damaged, and they want one more, and so the damage just keeps going along. It's like going and shooting someone, and that one becomes a shooter, and they shoot someone else, and they become a shooter, and they shoot someone else. And when they do that to the DNA, now we have problems because the DNA becomes damaged. Right? And you want good DNA, and you're not getting good DNA. So, from a nutrition standpoint, what you want to do for cancer is to eat a whole plant foods diet, right? Whole means that you can tell what the thing is, right? The closer it is to how it grows, the better it is for you. Like, beets are good. Beet chips are not as good. Right? Beet veggie sticks that are all full of air and all that kind of stuff, they're even less good for you, right?
The kale chips are so hot now. We have farmers in our group that have made them. A lot of food to make these kale chips. People were buying them off the shelf like that.
Oh, yeah. Yeah. So the closer it is to how it grows, the better it is for you. So whole foods, plant-based diet is really what you need to be looking at. We'll usually put individuals on about an 80% raw, so 80% of your plate being raw, 20% of your plate being cooked, right? And cooked is not bad. There are some nutrients that you get from broccoli cooked that you get a higher bioavailability of it than you do when it's raw. But there's other components of the broccoli that you have a better absorption and bioavailability when it's raw than when it's cooked. So it's good to have a combination of the two. Get a variety of colors. The variety of colors means that you're getting a variety of antioxidants, phytonutrients associated with it. And then you want to avoid the animal foods, dairy, eggs, processed carbohydrates, sugars, high fatty foods, and so on and so forth. All of those are going to be things that you love but do not love you in return, but your cancer loves it and it doesn't love you in return. Right? So stay away from those things. Eat the stuff above. Right? Exercise. Well, exercise is also very beneficial as well. We know in research that increased physical activity has been shown to decrease your risk of developing cancer in the first place. Right? So those who are more physically fit are less likely to develop cancer throughout their ages. And from some of the studies, we know that you can reduce your risk of colon cancer by about 40 to 50% by being regularly physically active. Breast cancer by 30 to 40%. We know that there's studies showing that uterine cancer, lung cancer, pancreatic cancer, and even prostate cancer can be decreased, your risk for it decreased by being fairly physically active. Prostate cancer almost up to 75%. What about if you have cancer? Does exercise help you? Yes, right? So individuals who have had cancer, there are studies showing that physical activity, increased physical activity, helps you to survive your cancer. Not just to not get it, but to survive it. Breast cancer, it increased survival of breast cancer by 26 to 40% in those who are exercising increased physical activity compared to those who have less physical activity. All right, when it comes to cancer treatments, what about sunshine? Do it, don't do it. All right. Well, what happens with sunshine? You've got 3 different types of ultraviolet radiation that are coming from the sun. You have UVA, UVB, and UVC. Anybody heard of UVC? No, you don't usually hear about UVC. Why don't you hear about it? Well, it's because it's usually filtered out in the atmosphere and it usually doesn't get to the Earth's surface. So we don't usually have to deal with it. UVA has a wavelength that allows it to get through the stratosphere, get through the ozone layer, and get all the way down to the surface. And UVA penetrates fairly deeply within the skin. It has the longest wavelengths, around 400 to 320 nanometers. UVB has the medium wavelengths, around 320 to 290 nanometers, and the UVC has the smallest wavelengths, around 290 to 100 nanometers. And UVC has the worst effect when it comes to cancer. It has the greatest energy to cause damage in the DNA and cause cancer, but it usually doesn't get to the Earth's surface. But in areas or locations where the ozone gets thin and disappears, guess what gets to the Earth's surface? UVC. Right? And UVC will get to the Earth's surface, and individuals who have sun exposure in areas where you have a lack of the ozone layer, they have significantly increased skin cancer rates. Why? Because they have UVC exposure with that. UVB is the one that's most prominently associated with skin cancer development, and we know that there's basal cell carcinoma, squamous cell carcinoma, melanoma, that can be associated with prolonged UVB exposure or burning, especially when one is younger, and then the risk increases then as you get older. The burning is younger, and then the cancer development is when you're older. All 3 of these forms of ultraviolet light can cause skin damage by damaging skin cancer by damaging the DNA of the skin cells. And if you're light-skinned, then you're more at risk. Right? If you're dark-skinned, you're less at risk. It's interesting that melanoma, malignant melanoma, most of the time develops in areas that doesn't have significant sun exposure. Places that typically is under clothing and is, it's not places that you're usually hanging out in the sunshine, right? most of the time it develops in areas that are actually not very sun exposed. So it makes us question about that exposure. Now, as I mentioned before, we have reviews of the literature that show that individuals who are vitamin D deficient are at significant increased risk for developing many different cancers, cardiovascular disease, and did I say diabetes? Diabetes, right? Blood sugar control and even weight control problems with individuals who are having low vitamin D levels, and certain neurologic problems. We know multiple sclerosis, there's some association between vitamin D levels and multiple sclerosis and some other neurodegenerative conditions. When you look at vitamin D deficiency, which is very prominent across the United States, the average vitamin D levels in the US are around 22, 23. Normal starts at 30 and goes up to 100. Ideal is around 60 to 75, so we're very low as far as our vitamin D levels are concerned. If we got our vitamin D levels up to the ideal range, there would be hundreds of thousands of people that wouldn't die from conditions associated with vitamin D deficiency that would live if they just got more sunshine exposure. And there would be a few more people who would develop skin cancer and die from it. And so the overall effect is that you would actually be much better off population-wise to get more sunshine exposure and get your nice vitamin D levels than you would to avoid the sunshine and avoid the potential complications associated with it. Give your throat a vacation. Smoke a fresh cigarette. Anybody want to give your throat a vacation and smoke a fresh cigarette?
No, better not smoke.
Oh, Camels recommended by more doctors than any other cigarette. Yeah, interesting enough. And that was, I don't know, that might actually have been an ad in the American Medical Association JAMA, Journal of American Medical Association. They used to have tobacco ads in there. Well, tobacco is responsible for about 30% of all cancer deaths in the United States, 80% of lung cancer deaths, and it's responsible for cancers of the mouth, larynx, pharynx, esophagus, kidneys, cervix, liver, bladder, pancreas, stomach, colon, rectum, and so on. Leukemia as well as a result of cigarette smoking. And the cigarette industry did a very good job of burying this for a long time, confusing the issues, putting controversial, research out there, paying off researchers, paying for research to be done, and then manipulating the numbers and so on and so forth. And then a lot of people are confused, and it delayed us getting to the real point of saying, okay, no more cigarettes. You know who's doing the same tactics now? And are being advised by some of the same advisory companies that were advising the tobacco industry back then? The food industry. Food industry is doing the very same thing now. Putting out contradictory studies. Now you're confused. I don't know. Is soy good? Is soy not good? Should I not do that? All right, dairy might be better. Like choline. Oh, eggs have choline. All right, eat it. You know, and all of this kind of stuff back together. You know, billions of dollars that are at risk here with the food industry, and some of the very same companies that were helping to advise and promote the tobacco industry are the very same ones that are advising yeah, it's money.
Now, organic
Yeah.
Wherever the money's going, that's what they're doing.
That's right. The Egg Board and the Good Dairy Cattlemen's Association and so on and so forth. All right. What about alcohol? Well, all types of alcohol can promote cancer. Right? Ethanol, acetaldehyde, they can promote estrogen, head, neck, liver, esophagus, breast, colon, rectum, and stomach cancers. are associated with it. Alcohol can, especially if you're looking at beer, beer with the hops, it increases the production and release of estrogen. And so estrogen-associated cancers tend to be much more prominent in individuals that are drinking beer and individuals who handle hops in the beer-making process. Right? So hops workers or hops handlers tend to have more issues or problems from that standpoint. But all types of alcohol end up being associated with various different cancers as well. So don't drink it. Don't use it. What about toxins? Oh, acetaldehyde, aflatoxin, asbestos, azathioprine, benzene, cadmium, coal, diesel exhaust, formaldehyde, HIV, HPV, HTLV1. These are all viruses. HHV8, outdoor air pollution, radon, silica dust, trichloroethylene, vinyl chloride, right? This is just a small little list picked out from a bunch of different things that are known to be cancer-causing. So what's the recommendation from this standpoint? Live in a bubble. If you don't want to live in a bubble, be careful about your environment, right? Know what your exposures are. Try to avoid too much contact with things that you're not supposed to necessarily be in contact with, right? Live as natural a life as you can, right? Instead of spending all of your days indoors, go out in the garden, right? Get outside rather than spending so much time inside. Don't use as much of the chemicals and all of that kind of stuff. Do things more naturally. Water is good. Right? And don't go kissing people that are sick. You might get some other stuff that you don't want. So what are some other things that you can do to treat cancer? Well, there's different herbs that are known to have benefit associated with cancer or treating cancer. One of those is sweet wormwood, also known as Artemisia annua. Sweet wormwood there are a number of studies looking at the use of sweet wormwood in a number of different cancer lines and significant improvements in cancer. In fact, they're trying to extract some of the chemicals that are in sweet wormwood so that they can concentrate it, purify it, and use it as a chemotherapeutic agent, right? Turmeric. Turmeric as well is another one that has quite a few studies associated with it. Uses internally as well as externally, whether you're looking at getting the root and using it or the powder, eating it on a regular basis. That has been shown to be beneficial. You can also use it externally. There's some studies that I've looked at, I think from India. And they were doing poultices over skin cancer lesions and over breast cancer and showing improvement in those cancers by using turmeric as part of the poultice going over those areas. So you can use it externally, you can use it internally. There's a number of studies looking at red clover and its ability to help out with cancer. We know red clover is a good blood cleanser. And it's something that you could take, and then you could take, and then you could take, and then you could take. You know, you could use it along with your water. There's not really much bad as far as side effects associated with it, unless you have an allergy to it, which is rare. I haven't found anybody yet that did, but it's possible.
Is that the same as crimson clover?
No, yeah,
Crimson clover for the animals, the goats, is real tall and it looks different from that in the way it comes up. And I mean, they eat it down. It really helps them.
And it's cheaper. But the red clover is more expensive if you're getting the red clover to grow it and then harvest it yourself. Because I think we made that mistake on the farm this last year, and we got the wrong clover. Black cumin. Black cumin seed is also something that has been shown, again, many different cell lines, and it's been shown to be beneficial. Most of the studies are using about a teaspoon's worth of the black cumin seed on a daily basis. And just like flaxseed, you get it, you grind it up, and you use it freshly ground sprinkle it on your food, put it in your smoothie or whatever you're doing, and take it that way.
And chia seeds, I always throw in chia seeds.
Chia.
Yeah.
Yep, chia seeds.
The
Yep.
stores right here in town has chia.
Yep.
People are looking for it, yeah.
Yeah, chia seeds very beneficial as well. Lots of omega-3 fatty acids. Chia seed has a similar profile as flaxseed does. And so with all the benefits of flaxseed, you see similar benefits with chia seed as well. Aloe. Aloe is another one that has a number of effects with a number of different cancers. Some people just like the taste of aloe. Other people do not at all like the taste of aloe. Most of the people are in the second group, and there's a few people I found in the first group. But aloe is very good. We have tons of aloe in our greenhouse, and so we use that with our guests at the Lifestyle Center fairly frequently. It's very good for digestive issues as well. You've got gastritis, heartburn or reflux esophagitis. It helps out very good with that. And then, of course, if you have burns, putting it on superficially. How much do you use? Well, we usually use somewhere around 1/3 of a cup 3 times a day, so you end up getting about a cup of aloe throughout the day. Some people can't tolerate that. Well, decrease it, chug it fast, and follow it with some lemon. And the lemon takes that taste away if you don't like it. There's also studies showing that the intake of shiitake and maitake mushrooms helps in the treatment of cancer and decreasing its effects. And so that's something that we'll use as well with individuals using shiitake and maitake mushrooms. And they can just be sauteed lightly, make nice and flavorful, and it's usually about 1/4 cup.
It's expensive. Are you growing shiitake? We did a workshop on that. You know, with the logs, they give you the logs when you pay for the class and put it out there on your farm.
Yeah, I've seen the pictures and descriptions of how you can make a log farm for your shiitake mushrooms, but we haven't attempted that. Yeah. And then there are hydrotherapy treatments that one can do. This is one of our treatment rooms with one of the fever baths in there. Hyperthermia or a fever bath, what's that? It's the torture chamber. What happens in a fever bath? Well, it's exactly that. You have a bath that has hot water. You submerge in it, right? And what it's doing is it's then increasing your temperature and creating an artificial fever. And so as your temperature goes up and you push that temperature level up, we are usually shooting for around 102 to 104 degrees. And we're trying to hold that for 20 or 30 minutes or so, and keeping your temperatures up there and then letting you cool off after a little bit afterwards and then rest. And doing that several days a week, several weeks, a month, for several months. There are a number of studies, these are just a few that I've picked up, looking at hyperthermia or increased body temperature and its effect on cancer. Cancer cells are less heat stable. They're more susceptible to heat damage. And so when you increase the temperature and increase the heat, they're more susceptible and they undergo this programmed cell death called apoptosis. And so you can help work against the cancer by doing these treatments. And there's somebody getting the treatment and chugging through it, right? And yes, you can repeat that several, 3 to 5 times a week, about 3 weeks out of a month. I'll usually, with individuals that have cancer, I'll usually advise them to continue that for about 6 months when they go home. Again, aiming for about 102 to 104 degrees. We have some individuals that tolerate more. We had one individual and he would do 106 to 106.5, and he tolerated just fine. It was okay. And then he would get done, and he'd get done with his hour rest, and he'd go for a walk. He was nice and happy with that.
Every night, just jump what we normally do. Jump in your jacuzzi for 20, 30 minutes and chill out with a hot bath.
Yeah, but this is, you don't want to chill out, you want to heat out. Yeah. Yeah, you want to get nice and hot, and measuring the oral temperature every 5 minutes to see where you're at, and once you get above 102, that's when your time starts. And then you hold it for about 20 minutes, 30 minutes, and then drop it back down. There's studies that they've done in Europe, and they're looking at about 107 degrees, 107.2 degrees, and maintaining that for a couple hours, and then bringing an individual back down. But they're using sedation, so they're doing sedation with the individuals, and then and tight monitoring of the temperature. And so using that as a sole modality for treatment. Much of the research that's going on currently is looking at hyperthermia treatments in conjunction with chemotherapy. Because it's considered unethical to not offer individuals the conventional treatment modalities, you can't devise a study that pits conventional therapy against some other kind of therapy, right? Or that tries conventional therapy versus no therapy. It's considered unethical, so you can't do the studies. But what you can do is you can add the other things too. So you got this group that's doing chemoradiation, you do this group that does chemoradiation and hyperthermia. Or this group that does chemoradiation and garlic, or so on and so forth. So you can do those studies, but you can't do them that goes, okay, we're going to do garlic versus chemo. Or we're going to do hyperthermia versus radiation. Or anything, it's considered unethical, so you can't do the studies. Obviously, when we come to treatment, prayer and trust in God is something that's very important, because who is it that ultimately can heal? That's God, right? Ultimately, He's the one that's going to be able to heal. Yes, He's put things in place in our bodies. Yes, He's put properties in place in His nature that He has created. But ultimately, the healing comes from Him. And if we go for everything else and we ignore Him, that's not a good plan. Right? It's not a good plan. And so coming to Him and trusting in Him to bring about the healing is important. Very important. So, who am I? What am I? I will not submit to anyone else's instructions. I am rebellious. Who am I? What am I? I will not cooperate and work together as a team. I am independent. Right? Who am I? What am I? I will not respect someone else's space. I'm inconsiderate. Well, who am I? What am I? I will strip others of their resources. I am competitive. Well, who am I? What am I? I will start small, hide when I grow, and not manifest my true character until late in the game. I am subtle. Right? Who am I? What am I? I will spread to other areas and take over. I am aggressive. Right? Who am I? What am I? I will remove your loved ones from you. I am malicious. Who am I? What am I? I will use more and more of your resources until you die. I am selfish. Who am I? What am I? I am seeking to be immortal by my own rules, but in the end, I will die. Who am I? What am I? I think that I'm God, and I demand everything for myself. Who am I? What am I? I make others sick and weak, cause them pain, and finally kill them. So who am I and what am I? It sure sounds like cancer. But I am sin. Right? And there's quite a remarkable correlation between sin and cancer. right? Between sin and cancer. And so it's a controversy between the Lord and the enemy. And we find the controversy being waged in us, right? And the question is, who ultimately will win? The Lord will, right? The Lord will. And while we think about cancer and we think about its effects and how it works and so on and so forth, and we think about the things that we can do, we ultimately must recognize that our struggle is not against flesh and blood, but our struggle is against principalities and powers and spiritual forces in the heavenly realms, right? And so we must wage the battle there. Even while we are faithful in the physical realm, we must recognize and be faithful in the spiritual realm as well. And as we do so, and as we trust in the Lord, and by His choosing and by His power, we may, by God's grace, be successful in reversing cancer naturally. But if we're not, if the cancer doesn't go away, if it doesn't turn around, if it doesn't slow down, does that mean that we're abandoned? No. Everyone whom Jesus healed, died. Lazarus was raised from the dead, but what happened to Lazarus later? He died. And the Jairus' daughter was raised from the dead, but what happened to her later? She died. And the son of the widow of Nain was raised from the dead, but what happened to him later? He died. Everyone whom Jesus healed, everyone that He raised from the dead, ended up dying. Right? Death rate is 100% minus 2. Enoch and Elijah. Those are the only 2 human beings that have ever escaped death. Right? And that's by God's grace, and He's coming back to take His children home. And whether He chooses to heal or not to heal in each individual's circumstance or situation, whether they're dealing with cancer or not, the outcome here and now is not what determines the whole game. Because He promised to come and take His children home to be with Him where He is. Right? He's going to make mansions for us. No, He's not. He said He has mansions for us. He's just preparing a place for us. And so as He does so, we have hope for a future. Right? Anybody who's interested, you can look up on YouTube and look up the pineapple story. It's a very funny mission story from a missionary. It's called the Pineapple Story. And just briefly, he's in a foreign mission field where the population always is involved in stealing. The parents teach their children how to steal, and they get after them if they get caught for stealing. And so everyone steals from everyone else, and it's just the norm that you steal from others, and that's just how it is. But when you come from America, and you're in America, and you're not used to people stealing, well, this missionary, he bought a pineapple patch, and they would steal his pineapples. Oh, and he was trying to teach them about Jesus and all that stuff, and they would steal his pineapples, and he would get angry, and they would come to his shop, and they would try to sell him his pineapples. Oh. And they would go, and they would find some of their stuff missing from their house, and they would go into town, and they would find people wearing their clothes. And the funny thing is the villagers would go around naked, but then they're wearing their shirt, but the rest of them naked. Or he had a pen, and his pen went missing, and he was walking down the street, and he saw one of the gentlemen, and the pen was sticking through his nose. And he went back angry and he took the pen away from the man. Here, give me my pen. And they were always stealing stuff from them and they weren't able to keep the stuff. And he was always angry and frustrated. And he was trying to teach them about God and the love of God. And finally they're starting to get it. The villagers said that and they said, we're waiting to see a Christian. He's been with them for years. He said, what do you mean? I've been with you for years. He said, well, no, you're teaching me about this Jesus and about Christians and what Christians are like. We're waiting to see a Christian. After years, he finally gave up. He said, you know what, Lord? I'm going to give up the pineapple patch. It's yours. I can't get any pineapples from it anyways. They're stealing it and all. I'm going to give it to you. Oh, there was a big uproar in the village because he mentioned to somebody that he gave the pineapple patch away. And they said, oh, who'd you give it to? He says, well, he didn't tell anyone. Hang on, we've got to know. And so they all got together. They had a whole big village council and the men were around and they were angry. They wanted to know who he gave his patch to. And he finally told them, I gave them to my God. And they all got together and they were talking and they were you know, all excited amongst each other. And they said, when did you give it to your God? I said, well, I don't know. I gave it to him like 5 or 6 weeks ago. And they got together and they were talking and stuff. And then they came back and they said, take your pineapple patch back from your God. He says, I don't want to. Take it back. No, I gave it away. I've been happier now in the last 6 weeks than I have been the rest of my life. And one of the guys that he'd been working with, he was like, yeah, he's a lot nice. You know, he's a lot nicer, and he's kind of like he's finally become a Christian. You know, he gave up his pineapple patch. Now he's finally a Christian. He's a nice guy now. And they're like, no, give it back. Why? Well, they hadn't been able to have babies, and this had been going wrong, and that's been going wrong, and that had been going wrong in the village ever since he had given his pineapple patch away, and they were stealing God's pineapples. And they didn't want it to belong to the God anymore. They wanted it to belong to him so they could steal his pineapples. He wouldn't take his pineapple patch back. It belonged to the Lord. And you know what? From time to time, he'd get pineapples on his porch. He didn't even have to go out and pick them. They'd leave them. Because they didn't want the curse associated with stealing God's pineapples. And he began to finally get more and more pineapples after he gave his pineapple patch away. And there was an interesting statement that he made in telling this story, and it's really funny. You got to watch it. There's an interesting statement that he made in this, and he said, in dealing with people who are sick, he said, and it's amazing how many people that I worked with, that when they gave up their right to be healthy, that they healed. When they gave up their right to be healthy. And that was just a kind of a side comment, and then he went on with the rest of the story, but it's one that I caught. And I was like, hang on. Ooh. There's a concept there that I need to understand. Sometimes we fight so hard for health. And we fight so hard to be healthy that we're anxious about being healthy. And we're frustrated when we're not. Why? We're trying to be in control of our lives. Now, it doesn't mean don't try to do healthy things, right? That doesn't mean don't adopt healthy behaviors. But we can even turn our health over to God and say, you know what, Lord? I'm going to give up the right to be healthy. I will do healthy things. I will cooperate with you from that standpoint. But whether I have health or not, I'm going to love you, and I'm going to serve you, and I'm going to help others, and I'm just going to live. And how many people in his experience have come to healing because they gave up their right to be healthy? And that's hard to do when you're facing a life-threatening disease like cancer. But I would encourage you, if you're ever in that situation or if you're in it now, turn over your pineapple patch, your cancer, your health, and that kind of stuff to the Lord. Do the healthy things, yes. But then let the Lord worry about whether that will result in the healing of that cancer or not. and just love Him and serve Him and love others and be like Jesus. And you will have peace even in the midst of your little storm. Let me pray. Dear Heavenly Father, we thank you for your abundant blessings and your good mercies to us. Lord, you are so good. And Lord, we ask for you to teach us to submit and surrender all of these things to you, that you may be in control. We don't stress about it, and we don't fret about it, and we don't try to control it and manipulate it and all that kind of stuff. Yes, we cooperate with you in doing that which is healthy and participating in those healthy behaviors and so on and so forth, but we also love others and help them, and we love you and take from you as our only source, that we may give to others good things. And Lord, may our joy be found simply in those relationships and in that taking from you and giving to others. And may we let you be in charge of whether we heal or not, and have peace in the midst of the process. And may you work out your abundant healing and grace in our lives, we pray. In Jesus' name.